When we look out into the cosmos, we see a vast, silent tapestry. To grasp its scale, we must recalibrate our minds. Our Milky Way galaxy, 100,000 light-years across, is just one of hundreds of billions. Galaxies themselves gather into clusters, and clusters string together into immense filaments, forming a great cosmic web. But for all this structure, our understanding of the universe rests on one fundamental pillar, the cosmological principle. This principle states that on the very largest scales, the universe is essentially the same everywhere. It is homogeneous and isotropic. If you zoom out far enough, the lumpy cosmic web should smooth out, like looking at a beach from so high up that you can no longer see the individual grains of sand, only a uniform stretch of shoreline. Our models are built on this assumption. They even give us a number, a theoretical speed limit on size. No single connected structure should be larger than about 1.2 billion light-years across. And then, we found them. First, we must understand the quasar. A quasar is a cosmic lighthouse, a beacon of unimaginable violence and brilliance. At its heart is a ravenous supermassive black hole, devouring so much matter that the disk of infalling gas and dust heats up and outshines its entire host galaxy by 1,000 times. Because they are so bright, we can see them from across the observable universe. They are the lampposts of the cosmic dawn. And in 2013, astronomers found a collection of these lampposts that defied belief. A congregation of 73 quasars, clustered together in a region of space so vast it shattered our sense of scale. They called it the huge LQG, or Large Quasar Group. Its size is almost incomprehensible. It stretches 4 billion light-years from end to end. If you could travel at the speed of light, it would take you 4 billion years to cross it. This is not a string of galaxies. It's a colossal structure more than 3 times larger than the theoretical maximum size allowed by the cosmological principle. It is a cosmic anomaly, a feature on the map of the universe that our rulebook says should not exist. The huge LQG and other similar structures since discovered presents us with a profound challenge. Is it a 1 in a trillion statistical fluke, a chance alignment of lighthouses that only appears to be a single entity? Or is it a genuine, gravitationally linked structure, a cosmic titan from the early universe? If it is real, then our fundamental assumption, the smooth, uniform nature of the cosmos on the largest scales, might be wrong, or at the very least, incomplete. These structures force us to ask new questions. Did the universe form structures more efficiently than we thought? Does a force or a mechanism we don't yet understand operate on these immense scales? Large quasar groups are not a failure of our theories. They are the sign of science working perfectly. They are cosmic question marks etched in light, pushing the boundaries of our knowledge and reminding us that in the grand, silent theater of the universe, there are still titans hiding in the dark, waiting to be discovered. From the moment we first looked up at the glittering tapestry of the night sky, a single profound question has echoed through human history. Are we alone? For millennia, that question was the domain of philosophers and dreamers. But now, in our time, it has become a question for science. With telescopes that can peer into the deepest recesses of the cosmos, we are no longer just guessing, we are searching. And what we are finding is staggering. Not just planets, but worlds. Worlds that orbit in the gentle, life-giving warmth of their parent stars. Consider Kepler 452b, a world some have called Earth's older cousin. It orbits a star very much like our own sun, but one that is 1.5 billion years older. This super-Earth is larger than our home, with a stronger pull of gravity. One can't help but wonder, if life arose there, what could it have become with such an immense head start? But its age is a double-edged sword. Its aging star now shines brighter, and Kepler 452b may be entering the final stages of a runaway greenhouse effect, a poignant reminder of the fragile window for life. But perhaps we are too narrow in our search. Perhaps life doesn't need a star like our own. Journey with us then to the system of Gliese 180, a mere 40 light-years away. It orbits a dim, cool red dwarf. Here, the habitable zone is huddled close to the star for warmth. At least one planet, Gliese 180d, a cold super-Earth, orbits comfortably within this region. Life here would be profoundly different. These worlds are likely tidally locked, one side in perpetual day, the other in eternal night. Could life thrive not under a wandering sun but in the endless twilight of the Terminator Zone, that sliver of a world between light and dark? It forces us to imagine biology born of stark contrasts. And then there are the candidates that make us hold our breath. The unconfirmed world of KOI 4878.01. If its existence is verified, it would be the most Earth-like planet ever discovered. It is almost exactly Earth's size, orbiting a sun-like star with a year lasting 449 days. Its calculated Earth similarity index is an astonishing 98%, a true terrestrial twin. Is there a world out there, drifting through the darkness with continents and oceans so similar to our own we might mistake it for home? Does it have its own clouds, its own rain, its own life? We don't have the answers yet. These worlds are impossibly distant, their secrets guarded by a vast gulf of space and time. But they are no longer just points of light. They are destinations. They are possibilities. For now, the cosmos remains silent. But in that silence, there is no longer emptiness, there is potential. And so, we listen, we watch, and we wonder, waiting for a whisper from across the cosmic ocean.